Hey, welcome back. We are going to go over the just-in-time review of interval notation and set builder notation. And we've already kind of touched a little bit on the interval notation. I want to make sure that we cover both, though. There is some overlap. The concepts are very similar. How they're presented, how they appear on paper and on graphs is a bit different, but the concepts behind them are very much the same. So if I had a case that I have A is going to be less than X, and that's going to be less than B. All right, we can write this we can write this 4 different ways. We can write this with the set builder notation. So set builder notation, interval notation, and then graphically. And there's 2 different ways. It's very, very similar when it's graphing. But I want to make sure that we're real clear on how that can happen. Now, normally the set builder and the first graph I'll show you go together, and then the interval notation and the second graph will go together. So, okay, in this case we have our A is less than B, and and it's less than X, okay? So our X is in between A and B. So the way we write it in set builder notation is we put it in a friend of mine calls these Hitchcocks, but curly brackets, right? So that we can say X such that, and this line up and down means such that A is going to be less than or X, which is less than B. And then we close that bracket. Here, we're not including A and B, right? So here we're going to have our parentheses, A, comma, B, which we've already talked a bit about. All right, and here's the set builder graph, okay? And I'm going to change this up so I have different color here. So I'm going to have my A and my B, and this normally goes with the set builder, okay? So this goes with this one, and then here I'm going to have an open dot, and I have an open dot here. That means we are not including them. When it's an open dot like that, it means we don't include that value. And I know that seems kind of superficial, but it's one way to address it. So that would be our graph using one of the 2 formats that you can do graphically. I'm going to go back to our different red, but it's okay. I'll put a star with that one. All right, so here I'm going to have my paren, right? Actually, let me put that in black. So my paren is my A, and there is my B, and those parens, I have everything in between there. All right. So that is very superficially how we go about writing and drawing these things graphically. I'm going to work a little more with the set builder notation. I want to kind of make certain that we're really clear on what's happening. Interval notation, hopefully we have a little bit of a handle on that, and I will kind of go through the process here so that we can determine how things would look. Now, this one was strictly less than and greater than, right? So here I have my strictly less than, and here's a strictly less than. Now I need to deal with what happens if I have, let me do a different color here. So what do I do if I have A is less than or equal to B, All right, yeah, let me undo that. So I'm going to have my A is less than or equal to my X, which is less than or equal to my B. In this case, my set builder notation is going to be this. I'm going to have my X such that, and that's, again, this is one of those moments where it's like we have something that looks similar to perhaps a parallel line symbol or an absolute value line. That is not what it means. This is known as a such that. That's, if you were to say it in English, the way you would read it is X such that A is going to be less than or equal to X, which is going to be less than or equal to B. All right, so here's my curly bracket, and I'm going to use this one here to, I'll try and pick a different color here in a moment for when we do the interval notation. So in this case, I have my A, and I'm going to fill in that dot because that's equal to, right? So I'm saying, here I'm saying I'm omitting that space. Here I'm saying I'm including it. So here's my B. And again, I'm going to have that solid bar or solid dot, and then I'm going to have everything in between there, okay? So there's my A and my B, and I'm including that dot, so I'm saying that it is equal to in both of those cases. Now let me go ahead and pick a different color. We'll pick that one. So I have my interval notation, which is going to be A with a square bracket opening, and then I'm going to have a B with a square bracket closing. All right, and in this case, again, we would have our square brackets. Let me make that a little taller. So that's a square bracket. There's my A, there's my B, and it's everything in between there. Okay, so that hopefully is, making it really clear what's happening. Let's actually do a couple of the problems, or do a couple problems with actual numbers in them, and hopefully that will help us make some sense of things. So if I am going to let's go between interval notation and set builder notation. So here I am going to have, let's go with this. So -5 with a square bracket, and then 6 with a square bracket. So we're going to write that in interval notation, right? That's our interval notation right there. I am going to write my set builder notation. I've got my curly bracket. Like I said, a friend of mine calls those Hitchcocks. So we're going to have our X, and you can use any variable you want. We normally use X just by default. You don't have to do that, but it's helpful if you do. At least keep consistent with your variables. Here we're going to have our -5, which is going to be less than or equal to our X, or whatever variable you chose, and then less than or equal to 6. And I'm going to quick graph that. I'm going to use my brackets in this case where I have a -5 and I have a 6, right? And here I'm going to use a solid dot and a solid dot, so I have a -5 and a 6 there, and everything in between here and everything in between here. Those are the solutions, okay? So everything in between, that works. All right, so I'm actually going to stop this, and I will resume in a second video here in a moment.